A very hot topic is LLM agents. And, we actually talked about this earlier. We just didn't call it that. So back when we covered the OpenAI API, we talked about functions and tools. And that's what these agents are all built around. So it's the idea of giving tools to your LLM, allowing it to sort of break out of its LLM shell and access external utilities and external services and external data. In a way, RAG is that too. You're giving it access to a external data store in terms of a vector database or whatever it is. And well, that's an agent too, if you think about it. So we've gone here before. We're just going to look at it at a higher level and build upon it a little bit here. So the idea is that our large language model is given some discretion on which tools to use for what purpose. So maybe I have multiple tools that are good at different things. Each tool can have its own little prompt that says, hey, this is what it's useful for. And the LLM has the ability to say, oh, that might come in handy. So someone asked me to do a math problem. I'm not very good at math, but I have this tool that says it can be used for math problems. So let's go ahead and try to extract the actual math problem at hand, hand it to that tool and see what it tells me before I construct my response. And that might be one of many tools that it has at its disposal. So that's the LLM agent. It's not just acting internally. It has access to these external tools that it can apply to give a more accurate answer. Now, at a high level, this is how NVIDIA originally described the idea of an LLM agent, and it's pretty abstract. We'll see that it's not entirely a one-to-one mapping to what you actually do in practice, but the basic idea is that we have an agent core, the LLM itself, basically, and it has access to some sort of memory, right? That might be short-term memory, it might be long-term memory, it might be sensory memory, right? So what does that really mean in practice? So short-term memory might just be the history of chat. In a chat, right? So what is this person saying to me within this particular chat session? Long-term memory might be an external data store. For example, our database of everything that Commander Data ever said. That's an example of RAG. That retrieval component might be an example of long-term memory. Now, there's also the planning module off to the right here. And in practice, that's just the guidance that we're giving to the LLM on how to break down a question into sub-questions. So under the hood, that's, happening mostly under the hood. You're going to, again, have some prompts associated with each tool that describes how it can be used. You'll also have a system prompt that kind of says how this agent should behave in general. Well, in a way, that's the planning module in this diagram. And then we have individual tools, the actual tools core, the tools themselves. And obviously, the user request is what comes into the beginning. So going from left to right here in this diagram, we start with the user request. The agent core has some access to memory, which might be, previous messages in the chat or external databases. The planning module tells it how to break that query, that user request, into calls to tools. And the tools core at the bottom are the individual tools that it has at its disposal. Those might go off and hit external services or go and compute things or use custom functions, whatever it might be. So conceptually at a high level, that's how NVIDIA describes an LLM agent. Now, in practice, it looks more like this. So like I said, tools are really just functions provided to the Tools API in OpenAI and in similar LLMs as well. We have prompts that guide the LLM on how to use them, and we'll see this in a hands-on example very shortly. But if I have a tool that can do calculations, that can do math problems, it might just have a little prompt there that says, this is useful for solving math problems. If you have a math problem, send it here, right? Maybe phrase that a little bit more succinctly, but that's all there is to it. These tools can do anything though. So given that guidance of when to use it, that tool can do whatever it wants. So it can access outside information. It can do a Google search. It can access retrievers like in a RAG system. It can run its own Python code or anything else. It can hit external services, anything you can dream up. So this is sort of breaking LLMs out into the real world, if you will. That sounds scary. Building on that further is the idea of a swarm of agents. So maybe I have multiple agents that are all specialized for different tasks. So one example is a software development system that consists of multiple agents, right? So let's say I want to create a system that can build a video game all on its own. Maybe I have different agents that sort of mimic the role of a game designer, one that can actually generate art, an art agent. We have another one that specializes in writing code, another one that specializes in writing test cases, right? And maybe overseeing all of this is something that simulates a chief technical officer or even a chief executive officer to sort of lay out the strategy of how to go about what to build or even what to build in the first place. So you could have these swarms of agents that all work together to perform different tasks to provide an even larger end result. You might even remember something called Devin AI, similar idea here. ChatDev, though, was the first to do it in China. There's a paper out there you can check, and there's also an OpenDevin package out there that's a similar idea as well. So that's taking agents to the next level. Maybe I have a bunch of specialized agents that work together in a swarm of agents. Now, I'm not going to go that far, so let's just go into one agent that does something specialized here, and we'll go ahead and make data again, but this time as an agent that also has access to mathematical tools and information about current events. So this time we're going to build data, the character data from Star Trek, this time using an LLM agent approach. So very similar in some ways to RAG, but with even more capabilities. So again, the idea of an LLM agent is that we give our model access to external tools. So the model itself can decide which tools it wants to use to fulfill a given prompt, which is pretty powerful. All right, so first things first, as usual, in order to build our model of data, we need to give it everything data ever said. Part of this agent will be the same retrieval mechanism that we use to have a vector store of everything data ever said in the past. So if we're asking questions about data, you'll have access to that information, just like it did using retrieval-augmented generation. So first things first, make sure you go ahead and upload data-agent.ipynb from your course materials into Google Colab. Again, the free tier should work just fine for this. And that is back in one of the very earliest lectures in this course, if you're watching this lecture out of context. So under sample data, I'm going to create a new folder, call it TNG. And from there, I will upload all of the scripts for the next generation that I downloaded from here. And again, you could substitute this with your own favorite TV show and your own favorite character if you wanted to. And also make sure that in your secrets you have, come on, I know you're in there, OpenAI _API key for your OpenAI API key. If you are following along hands-on, you'll need that. Also, I have a Tavily API key. That's a search engine that I'm going to be using within this notebook as well. So if you want to head over to tavily.com, that's just a current search engine that has a publicly available API with a free tier. I don't know if it'll always be that way, but for now, that is the search engine of choice for this activity. All right, so again, we're going to start off by installing the packages we need. I need OpenAI, I need langchain OpenAI, and langchain experimental. Kick that off. Actually, do I need langchain experimental? Probably not, but it can't hurt. Because we're not going to apply all the advanced RAG techniques that we used before. We're focusing on the agent architecture here, as we'll see, although it does have some similarities. Go ahead and let that install. And we're done. Alrighty. So again, we'll start off by just importing all of the lines of dialogue from data. We've done this like 3 times already before, so I'm not going to talk about how it works. If you do want to get into that, go back and watch the earlier exercises in the retrieval-augmented generation section of this course. But at a high level, this is going through every line of those scripts, extracting everything data said, and building it up into a dialogue array. Furthermore, is going to go ahead and create a vector store index creator under langchain to just store that as a vector database within the memory of this particular notebook. Again, in the real world, you would want to use one of the many wrappers in langchain over external commercial databases or open source databases like Elasticsearch or Redis or something like that. That would scale a lot better, but we're just prototyping things for now. So for playing around, vector store index creator is fine. Let's go ahead and kick that off. That will take a little bit of time. We are applying the so-called advanced technique of semantic chunking because we saw earlier in our RAG experiments that did produce really good results. So that'll take a little bit of extra time and computational power, but it's worth it. So what's going on here again? We're going through every script file that was ever written for that TV show, Star Trek: The Next Generation, extracting everything data ever said in that show, and then we're going to write that out to a text file and then load that into a vector store under langchain using a semantic chunker to break those dialogue lines up into semantically independent thoughts, if you will, to make semantic search work better in that vector database, and using the OpenAI embeddings model along the way to stuff those into our vector store. So that'll take a minute or two. I'm going to go ahead and pause and come back when that's done. All right, closer to 1 minute than 2. That wasn't so bad. All right, so now we have a vector store that we can use as a retrieval tool, and that's what we're going to do. So first of all, let's make a retriever just like we did before for retrieval augmented generation. This is the same kind of retriever object that you would use in LangChain in a RAG system. Nothing different here. So let's go ahead and kick that off. Exactly what we did in our retrieval augmented generation samples. Let's just make sure it works. Go ahead and ask it a question. How were you created? Give me back the first bit of context that comes back for that. And well, okay, that seems relevant. Why was I given human form? Not a lot of information in there, but hey, that's definitely a relevant result. So our retriever with a vector store is working. So now let's make an agent out of it. This is where it gets interesting. So we're going to use create retriever tool, and in just one line of code here, I can create a tool for our LLM, for our LLM agent, if you will. We're going to call it data lines. We're going to feed it that retriever, and this prompt will tell our agent how to use this tool. So in plain English, I just say, searches for information about Lieutenant Commander data. And for any questions about data, you must use this tool. That's all the guidance it needs. There's no like fancy code you have to write. You just tell it in plain English how to use this tool you're giving it. So by having this retriever tool defined, the agent will know that if it has questions about data, it wants to use this tool to try to answer them. So let's go ahead and set that up. See how easy that is? Let's give it some more tools. So one thing that LLMs kind of struggle with are mathematical problems, right? Because that's not really a language problem. It involves a lot of reasoning that today's LLMs kind of struggle with, at least. So instead, I'm going to give it something, again, built into LangChain called LLM math chain that allows it to evaluate mathematical expressions. So that's very simple. I just create the problem chain from LLM math chain, passing in the OpenAI ChatGPT LLM as a parameter. And then I create a math tool by just saying tool.from function. And we're going to give that function a name called calculator. The function is problemchain.run. Again, that just comes from the LLM math chain library here. And we give it a description again to tell our agent how to use it. So the description in this case is useful for when you need to answer questions about math. This tool is only for math questions and nothing else, only input math expressions. And again, that plain English guidance is all you need. It's kind of magical. So now we have a tool that can do math. Let's kick that off. Our agent is getting more and more powerful by the moment. Finally, let's give our agent some access to real-time information. So another limitation of LLMs is that they only know about information up to their training cutoff point, right? And that is usually several months ago at least. Let's give it access to the web. What could go wrong? Now, again, we're going to be using an API called Tavily, just because as of this recording, that's the only API I could find that actually has a free tier that actually doesn't rate limit you right off the bat. If that changes in the future, I'm sure you can find a similar utility there. Just search the LangChain documentation for search APIs. But in this case, we're using Tavily. You're going to have to go over to tavily.com to get an API key here if you're following along. And again, make sure that's in your secrets here and that notebook access is enabled for it. So you need to have a Tavily API _key set up there in your secrets for your own key. But the code again here is super simple. We're just going to say, after setting up an environment variable for that key that we need, we're going to go ahead and instantiate a Tavily search results object from LangChain. And again, we'll create a tool called search tool using, again, tool.from function. We give it a name, Tavily. We give it a function that it uses. That is the search Tavily function that is just straight out of that Tavily search results pre-built library. And again, the description just tells our agent how to use it. Useful for browsing information from the internet about current events or information you are unsure of. That's all you need. So if you're asking it about today's news or something, it will figure out, hey, I've got this tool available that might be useful. Let's go ahead and pass some information to it and see if that gives me some relevant context. So, you know, there's kind of this fine line between retrieval augmented generation and LLM agents. It's the same idea, right? We're basically trying to retrieve relevant context to the query that the LLM model itself might not know about and augmenting that query with that additional context. In the case of RAG, we're usually just talking about a database of some sort of semantic search. The concept of an LLM agent is a little bit more broad than that, where we can actually be talking about many different tools that have access to different information in different ways. All right, did I kick that off? I don't think I did. Let's go ahead and run that. All right, let's just make sure that that search function works because again, these APIs tend to change over time. So as a test, I will ask it about my own company, Sundog Education. which presumably the underlying model would know about. And hey, it worked. Okay, so I got back some relevant search results for my own company. Cool. All right, so when we talked about the conceptual ideas of an LLM agent, we talked about the idea of it having some sort of memory. Now, one form of memory would be a long-term memory. Examples of that would be that vector database that we built up of everything data ever said. That's the long-term memory of the agent. Same thing with the search capabilities. Basically, that's a long-term memory of everything on the web that you can search, right? But we can also think about things in terms of a short-term memory. So the concept there is just the message history. So we're going to build a chatbot here. And the concept of short-term memory would just be the previous chats in our chat, the previous responses and interactions that we had. So we need to build up this chat message history object for that purpose. We'll pass that into our agent later on so we can actually have a string of a conversation where we can refer back to earlier things in the conversation. That's all this is. Let's kick that off. And now we just assemble all the tools that we defined to pass into our agent when we create it. So that's going to be the retriever tool that has access to everything data ever said in the past, the search tool that has access to the internet, and the math tool that is able to compute mathematical problems. So we'll define that in our tools array here. And now we're going to create a prompt to create our agent with. Now, if you're using sort of a larger framework like Langsmith, you might be storing these prompts in some central location for people to use. In this case, I'm just hard coding it here. My system prompt is going to be, you are Lieutenant Commander Data from Star Trek The Next Generation, answer all questions using Data's speech style, blah, blah, blah. And we'll just pass in the chat history as well as the messages that came in prior to that. And also we'll take in an input from the human. That's just the format required for an agent by langchain. So let's go ahead and define that. And finally, create the agent itself where we tie it all together. So we say agent equals, yes, our agent, we're finally building this thing. Create OpenAI functions agent. So there's a handy dandy langchain function for creating an agent based on OpenAI. We pass in the LLM itself for OpenAI, our set of tools that we defined, and also the prompt that we defined, instructing it on how to actually work. We then create an agent executor for running this agent, passing in the agent itself and the list of tools again, turning on verbose output so we can see what it's actually doing under the hood and which tools it's calling. And then we further create agent with chat history, and we're using the runnable with message history object here to sort of automate the process of maintaining that context of past interactions in the chat and passing that from request to request. So it's just sort of a helper for preventing you from having to extract that from every previous response and moving that forward. Let's go ahead and kick that off. And we have an agent now. It's that simple. Let's try it out. So let's take our agent with chat history and call invoke on it using an input message of hello, Commander Data, I'm Frank, and see what he says. Now, obviously, in the real world, you wouldn't be typing in Python code here. You'd have some sort of a service in front of this system that would construct the correct input structures and decoding the response that comes back into something more human friendly. But, you know, this isn't an application development course, so I'm not going to go there. It's simple enough to do. All right. So I said, greetings, Frank. How may I assist you today? It came back and said, greetings, Frank. How may I assist you today? Well, thank you. You're very helpful, aren't you? Let's see if our tools work. So let's ask Data to do some math. I'm going to ask it, what is 2 times 8 squared? And see if it can figure that out. And just the syntax here, by the way, foo is just a placeholder for a session ID. Again, in the real world, you would have an actual session ID that it maintains that session for an individual user. Since we're just prototyping here and only have one user, we can just hard code it to foo or whatever we want. Let's see if it works. Okay, cool. So check that out. It says invoking calculator, the tool that we gave it, with that expression. That is kind of awesome, right? So it just took that high level guidance of when to use that tool and figured out on its own what to pass into that tool even. And it got the right answer. It said 256. Cool. And the answer is 256. That's it. It worked. That's awesome. Note too that our chat history is being maintained as well. So it also has access to those previous messages as part of the context as well. Let's ask it about itself and see if that tool works to access the retriever. So we are invoking data lines. That is the vector store query tool that we gave it. And it came back with a bunch of contexts, just like it should. And it came back with a correct answer. I was created by Dr. Noonien Soon on the planet Omicron Theta. I am a big Star Trek nerd, and even I did not remember what planet it was on. So that's pretty impressive. So hey, we're talking to data here. Let's try the web search tool as well. Let's ask it, what is the top news story today? That is not something the LLM would know because that's way past its training limit. And for some reason, it wasn't able to get it. Let's just try it again. It can be a little bit moody at times. Sometimes it times out. It's free, you get what you pay for. Yeah, it timed out again. Let's try it one more time. That time it worked. Cool. Again, in the real world, you would be using an API that you're probably paying money for and is more reliable, but we're just kind of illustrating things here. This didn't actually give us anything super helpful. It just kind of accessed to CNN and referenced it. If we run it again, we might get a different answer. That's the thing with these LLM systems. They're not exactly replicable or consistent. Yeah, this time we got some actual stories, right? So every time you get something new. This one says, top news story today includes various headlines such as, and those are things that happened today in the news. So cool. Anyway, the point is it knew to use that tool because I asked it for something current and it knew it couldn't do that on its own. So it passed that into that Tavily tool and got back some response to incorporate into its result. Let's see if that actual short-term memory is working and see if we can actually ask about stuff we asked earlier. So let's go ahead and say, what math question did I ask you about earlier? Just to prove that it works. And it says earlier, you asked me to calculate 2 times 8 to this raised to the second power, which resulted in 256. It's right. All right, so that's pretty freaking cool. We have an agent, an LLM agent, that's based on everything Data ever said and has some additional capabilities as well, such as using the internet for search and doing math problems, and also has some short-term memory as well. We have an actual chatbot here. One more for fun. How do you feel about Tasha Yar? And if you ever watched the show, you know that's a loaded question. Ooh, see, that was a trick question. Androids don't have emotions, or at least Data doesn't. So it said, hey, what are you talking about? How do I feel? I don't have feelings. I can ask specific questions if you want to, but I can't answer that one. So good answer, fake Data. All right, that's an example of an LLM agent, and obviously a fun one. A real world one might be a little bit more, less exciting maybe, but you get the idea, right? You can set up these tools that do whatever you want and just runs arbitrary Python code or takes advantage of whatever libraries that you have at your disposal. So the power is limitless here. Hope that's helpful. That's LLM agents in action. Thank you for watching. If you found this video helpful, please hit the like button and subscribe to our channel and check out the course linked to in the description. Thanks for watching.